operations on the high seas is one of great diversity. Some of the largest and most impressive of these marine engineering wonders are the heavy lift ships. When it comes to piggybacking huge cargoes on the world's oceans, shipping companies, oil drillers, and the United States Navy turn to these giants of the seas, including Dockwise Shipping's massive Blue Marlin.
The Blue Marlin is indeed the largest heavy lift ship in the world by a considerable margin. She's 737 feet long overall and 206 feet wide.
The ingenious process by which heavy objects are loaded onto the huge ship is one of the marvels of modern naval engineering. Here, the Blue Marlin prepares to transport the massive Thunder Horse oil drilling and production platform from Korea to the Gulf of Mexico.
The Thunder Horse is definitely the largest oil and gas floating offshore platform ever built. It will weigh, at the time we transport it, some 60,000 metric tons.
Key to the loading process is the ship's ability to partially self-submerge.
It takes about 4 hours to fully submerge the deck of the ship by adding ballast water to ballast tanks within the ship to safely submerge it. And you'll note on the aft end of the vessel are two large, what we call buoyancy towers. These towers also contain ballast tanks, which we will fill with water, which enable the ship to submerge on an even keel.
Maneuvering the giant oil platform into place is a delicate operation, even though it involves thousands of tons of equipment and thousands of horsepower.
In using tugboats, the floating cargo is brought over the deck of our ship, whereupon we attach winch wires to the cargo from winch towers on the vessel. We then slowly bring the cargo over the deck of the ship into precisely the right position.
The final part of the operation comes when the Blue Marlin is resurfaced to her product. Perhaps the Blue Marlin's greatest moment of glory came when she was chosen to ferry the stricken Navy destroyer USS Cole back to the United States after it was attacked by terrorists in Yemen in October of 2000.
The hole in the side of the Cole was very big and made the vessel unseaworthy. So basically the challenge in loading the USS Cole was not so much the weight of the ship, because a destroyer like that weighs about 8,500 tons, which for the Blue Marlin is a relatively insignificant amount of weight. The challenge really was more, how do you put a long, narrow body like the Cole onto the top of our ship and stabilize it so that it doesn't tip over. The transport of the Cole was very smooth, very uneventful voyage, very successful, I would say, on the part of Dockwise and the U.S. Navy.
Another class of ocean giant that boggles the mind is that of oil drill ships. The biggest of them is Transocean's Discoverer Enterprise.
The ship's 835 feet long, 125 feet wide. The derrick tower is more than 375 feet over the surface of the water above the bridge.
Drill ships ply the oceans, exploring their depths for oil and gas fields. As oil reserves dwindle onshore and along coastlines, oil companies are turning more and more to deep-sea exploration.
The need for additional reserves in oil and gas production has driven the industry into ultra-deep water. In order to satisfy our clients and reach these new frontiers, we have to continue to develop bigger and better tools.
The Discoverer Enterprise's hull was built at the Estano shipyard in El Ferrol, Spain. She was completed in Pascagoula, Mississippi in 1999. The ship isn't just big, she's revolutionary.
We decided to throw out all the conventional thinking and start all over with a clean sheet of paper. Part of that process led to the development of what we call dual activity drilling, where we utilize two complete sets of equipment on one rig to be able to drill 2 wells simultaneously. The ship is so big because it has to accommodate 2 complete sets of drilling equipment.
This dual drilling capability allows the Discoverer Enterprise's clients to save up to 40% developing oil fields because it speeds up the whole process. The ship often operates in such deep water that anchoring while drilling is impractical. Instead, an ingenious high-tech stabilizing system has been developed.
We use what's called dynamic positioning. Dynamic positioning consists of computer-controlled thrusters that have inputs from satellites for positioning. We take inputs from satellites to determine what our position is. We then use a computer to very tightly control the position of the vessel using 7,000 horsepower thrusters.
The system is so efficient that it can hold the ship steady in gales up to 70 miles per hour.
In very high winds, in fact, we're able to maintain location within a few tens of feet in thousands and thousands of feet of water.
All of this combined technology adds up to a truly amazing ship. One that is capable of digging to incredible depths.
The ship is capable of drilling in 10,000 feet of water or more. In addition, even in that water depth, we can drill wells that are nearly 5 miles deep below the seafloor.
Oil drill ships may be the champs for digging deep into the earth beneath the sea. But when it comes to digging on land, nothing can top the giant excavators. The engines aboard the Discoverer Enterprise can generate enough power to serve approximately 40,000 homes. More of the world's biggest machines will return on Modern Marvels. When it comes to super-sized machines, giant earth movers are at the starting point of our world economy.
Without them, it just would not function. All raw materials have to be mined to produce the cars we drive, the streets we drive on, the buildings we work in.
Among the biggest of all earth movers are giant bucket wheel excavators. Some reaching over 700 feet in length, 300 feet in height, and weighing as much as 30 million pounds. They're the largest machines on land capable of
मैंने उसको भेजा तेरे को भेजा ठीक है
gigantic, incredible, amazing, and stupendous. You have to see them to believe them, and even then, you might not. Now, more of the world's biggest machines. All earth movers are giant bucket wheel excavators. Some reaching over 700 feet in length, 300 feet in height, and weighing as much as 30 million pounds. They're the largest machines on land capable of moving under their own power. Bucket wheel excavators, or BWEs, are used primarily to mine lignite, or brown coal.
It works best in loose, sandy material. The digging wheel and its multi-buckets is not designed for digging through solid rock or glacier-type boulders. It needs looser, more gravelly-type material to dig through efficiently.
This giant erector set of a machine is made up of many components.
You have the large digging wheel at the front, which is 71 feet in diameter. It is connected to a large boom, which then connects to the central tower. The central tower has a conveyor bridge, which extends from the back end of that, and then that is hooked to what is referred to as a discharge unit. The discharge unit carries the material onto large overland conveyors.
Although incredibly efficient as earth movers, BWEs pose no threat to the world's land speed record.
The speed of these machines are up to perhaps maybe about 30 feet per minute, which would translate into about 1/3 of a mile per hour.
However, the fact that they can move at all is a technological miracle brought about through the use of giant crawlers.
The main tower assembly is supported by an undercarriage with 12 massive crawlers, each 49 feet in length. The reason that these bucket wheel excavators like 293 require so many crawlers is for flotation. Because of the underfooting that the machine works on, it has to be extremely level, extremely stable.
Computers allow the operators to monitor all aspects of the digging operation. But even with this technology, several crew members are needed to operate the machine.
These machines typically run by about 4 or 5 people. There is one operator that is located in the main operator's cab. This operator would have an overall control of the whole machine.
The price tag for one of these brutes is as big as the machine itself.
The bucket wheel excavator of this size cost over $100 million. The weight of the machine, obviously a major factor in determining the cost of the machine, and the sophistication of the equipment.
Yet if you want to move an astonishing 314,000 cubic yards of material in one day, a giant bucket wheel excavator is the only way to go. Another Goliath amongst earth-moving machines is the Terex O&K RH400 hydraulic front shovel excavator.
The RH400 is the world's largest front shovel. 57 cubic yard bucket, 4,400 horsepower, 1,100 tons operating weight. It is simply huge. There has never been another hydraulic excavator like the RH400. Everything kind of looks like it's out of a science fiction novel or something.
With its gigantic bucket, it's able to do the work of many smaller excavators in less time, and with more efficiency.
The RH400's large bucket is capable of loading a 240-ton capacity truck 3 quick passes, with each pass averaging less than 29 seconds.
One of the main advantages of a hydraulic diesel shovel is its mobility. Unlike some electric shovels tethered to power lines, it can move freely.
Once it's finished working at a location, it can relatively quickly move to another working location and go right to work.
Mining companies thinking of buying the giant shovel can also expect to shovel out a lot of cash.
They have to be ready to write a big check for, in the neighborhood of $10 to $11 million. But because of their size and their massive capacities, their productivity should outweigh the cost of the machine in the long run.
And speaking of long runs, in the world of publishing, huge new printing presses are bringing a whole new meaning to the words, power of the press. Except for maintenance days, bucket wheel excavators work 7 days a week, 24 hours a day, 365 days a year. More of the world's biggest machines will return on Modern Marvels. Possibly more than any other invention, the printing press changed the world. And now, they're among the world's biggest machines. Prior to the invention of the press, written information was available only to an elite few who read books that had been written by hand. Johannes Gutenberg developed the first press with movable type in Germany around 1440. After its invention, knowledge about science, literature, technology, and journalism became available to everyone and spread across the globe. Today's presses are giant machines, often housed in buildings acres in size, and capable of printing billions of pages per week. The new $72 million press system for the Indianapolis Star newspaper is one of the most advanced in the country.
This is one of the largest press systems in the world. It stretches almost 400 feet in length and is 65 feet high. It's made up of 24 towers and 4 locations with folders. It can actually be run as 4 individual presses, or it can be run as a series of presses connected, and that's the reason it's all in one long line.
The first step in putting news to print comes when stories are electronically transmitted to the press site from the Star's downtown Indianapolis newsroom.
Once that page is transmitted out here, we output the page through a film processor that provides us with a large, full-size page negative that we then take and move over to our plate-making machines. The plate-making machines then have light that exposes the negative onto the plate, and the plate then has the finished image that we want to reproduce. The plate is then moved out into the press room and put on the cylinders of the press in preparation for printing the product.
Next, a web of newsprint is threaded through the press in preparation for the printing process. Then the giant machine is brought to life with a push of a button. The entire system is completely computerized.
Everything on the press can be controlled from this location. As the web passes through the press, there are sensors that tell us what the tension is of the paper. The better the tension and the more accurate we run the tension, the better the reproduction as the paper goes through the press.
Feeding this giant beast with newsprint is a never-ending task.
This is our newsprint supply warehouse. We have a 25-day supply of newspaper in this warehouse. Each one of the rolls will unwind to about 11.5 miles worth of newsprint.
Deep in the bowels of the press building, a complex automated system has been built to get the giant newsprint rolls to the press as quickly and safely as possible. The awesome machine's demand for ink is also insatiable.
This is our ink tank farm. We've got 6 large tanks here, 2 7,500-gallon black tanks, and 4 2,500-gallon tanks that we use for our blue, red, yellow, and spot red colors. During the course of the year, we'll use over 200,000 gallons of ink.
One unexpected byproduct that resulted from the installation of the new presses was the amount of climbing workers had to do to maintain them.
I would say that overall our operators consistently lost a few pounds each moving to working on these presses because of the size of them.
Papers rumble through the press at up to 25 miles per hour. Yet it's so well engineered that vibration is minimal.
We can take a penny and balance a penny on edge on the side trim of the press when it's running 75,000 an hour, and it will stay standing up for as long as you leave it there.
After the papers are printed, they're automatically sent to the packaging department.
Now, the gripper conveyor is like a series of hands that have fingers on it that pick up each paper individually and then take those papers to our mailroom department or our packaging department. In our packaging department, we would take those papers, we'd drop them off and put them into another in-feed conveyor where they go into a stacker where stacks of newspapers are created. We put a tie around those papers, then they get sent out to our distribution centers.
With a possible combined output of 300,000 copies per hour, this giant printing press system adds some real mass to the notion of communication. Of course, another media titan is the television. From the days when screens were only inches wide to today's mammoth screens, it's a technological wonder. Giant LED or light-emitting diode screens have become fixtures throughout the world. The largest continuous LED screen in the world is located at the capital of all things extreme and extravagant, Las Vegas, Nevada. By day, thousands of tourists pass right under it, many of them unaware that